Hello IPXers, we are chatting today to Mandy from Vanix, who is all the way from India. Of course, he's not all the way from India if you're in India. He's in India. I'm all the way from the UK. If you're in India, it's the other way around. Mandy, tell us about how Vanix changes the world for professional design engineers, how you disrupt it, what you do, and then we'll get into a chat. Over to you.
Thanks for this wonderful opportunity where we can showcase from India like what kind of global impact and changes we are making from the technology perspective. So basically, at Vanix, we are a bunch of engineers, bunch of researchers, which are working toward making a sustainable future for it. We are working basically around e-mobility sectors. We are making hardware. We are making firmware. We are making end-to-end stack where we can have full control to drive this optimization feast in a very good manner. So e-mobility and asset tracking is kind of the sectors which we are working, and we are making made in India hardwares, which are custom AI accelerated. You are well aware with like how this nowadays the compute requirement is increasingly required at the edge or near edge, we
Yep,
can say. So we are making such
yep.
devices which can take hold of all this e-mobility problems and challenges, and can bring more optimized, efficient output as compared to what conventional solution has to offer. We'll discuss in detail
Okay.
about the products. That's a brief.
Yeah, so let's talk about the products. Describe the kind of products that you create that enable them in e-mobility and asset tracking that will help them do that. So what do they actually buy from you?
So I will give like a background so that listeners can relate what kind of technology and application it has basically. So we are working around lithium ion and LFP batteries. And when we say batteries, we are saying that we are working for EV. We like electrical vehicles runs on batteries, and what happens is these batteries are going with lot of charging and discharging cycles. They are not like IC engines basically. So there are a lot of monitoring and lot of control gives the end user that okay, so let's say the end user is a battery manufacturer or battery OEM. So we give them insight, like how your battery is performing longitudinally, what are the faults you are getting more frequently, and all those kind of aspects, so that they can take those feedback and build the more improved versions. For the vendors which sell this battery from the OEMs, we provide them like this insight scores basically. So how the driver is driving and all. So basically they sell these batteries to fleet owners. And then other is like some of very interesting vertical with such kind of devices nowadays is
So just
started
so I can
coming
be
by. Yeah.
just so I can be clear, do they buy a sub-assembly board that has components on it and then it has your proprietary software on it? So have you taken products from semiconductor manufacturers like FPGAs, for instance, and you've put them on a board, and then that board then sits and monitors the battery? Is that what they actually buy from you? So if I'm a design engineer, I need to understand, if I'm watching this video, what is it that if I come to Vanix to solve a problem, what is it that I'm actually getting from you?
We don't manufacture as per se, so we have manufacturing partners. So what we do is we design this all hardwares first. So first offering is our device that can be directly plugged. We call it AI IoT device. We have different versions of it. So we give this hardware, and what happens is with this battery, every battery have different protocol versions to be worked with. So when this device is interacting with the battery, so they have their common language. We call it DBF. It's a protocol every battery works on it. The basically when we are saying battery, it's essentially the BMS, the battery management systems. So so we make this customized changes for each battery vendors, and make the firmware changes, and provide them. And we have an extra layer of offering in the terms of SaaS. So we have our own SaaS, but what happens is some customer doesn't require SaaS, some customers want have required SaaS. So we sell a bundle. You can take it in a bundle form: hardware, firmware, software, or you can take the hardware or firmware. That's also fine with us.
Right. So what is that hardware? So you talk battery management system, which you shorten to BMS. So we know that in an EV, they've got batteries. We know that. That's how they go. That's how they drive. And and we know that you have to manage that battery to make it as efficient as possible. So it lasts longer, it charges efficiently. So what you're saying is you offer a battery management system. You're describing that it's hardware and it's software and it's a SaaS, so it communicates with the cloud or wherever you want to send your data. So what exactly is that BMS? What exactly is that?
Okay. So now, like I want to clarify here, BMS is what is a controller basically, which is balancing all the battery cells. So that's we are calling it BMS. Our device is BMS monitoring device basically.
Yes.
And on these devices we have different variants. So what we so this particular hardware, it consists of battery protection circuits, main SoC, which is main brain of this, and we have certain specific sensors. For example, on board we have accelerometer sensors. Why? Because whenever some more acceleration, more speed, and those kind of aspects are there, we are measuring that also. We have this called battery protection circuit, where the power, because one of the common problem with BMSs is some BMSs works on different voltages. So some might work on 55 voltage, some might work on 96 voltage, and some might work on 150 volt also, depending on the size of battery. So we have a battery management circuit sitting on the hardware, which is taking accordance of all the voltage levels and making it be suitable for different voltage ranges. So that's one of
Yep.
the key part. Sensor is the key part, and
Yep.
SoC is the key part. And that SoC comprises of GPS, GSM, and all different other sub ICs. So that's a combination of this. So that's are the essential
Right. So
components on the hardware.
that I'm buying a board and it's got certain silicon on it. Whose silicon do you put on those boards in order to do that? Who have you chosen as your partners to do that?
Correct. So we have multiple partners. So when like the criteria for choosing the partners for this kind of SoC is we need the GSM capability, we need the GPS capability, we need the CAN communication capability, and we need some memory like sitting on the that SoC, some internal memory, either DRAM or those aspects. So currently we have partnered with Quectel. We have partner, like we are working closely on the Cavalry modules. We are also closely working on the STM modules. So we use different SoCs of STM into this, specifically for the CAN communication and flash related thing. So what happens is we also use external circuitry to put, because a lot of other aspects which are also we are being taken care of, like your OTA. So on these AI IoT devices, over the firmware updates kind of functionality is much needed. So where we need some extra memory on the onboard, where we can store securely our files. Lot of authentication configuration files are there for the firmware aspect, which has to be on the hardware every time. So memory is one of the key concern. Either it's onboard memory for the SoC, and either externally we have provided. So we provide in both cases.
Right. Okay. So what we're talking about, I mean, EVs are huge in India, massive market, growing. People use the word exponential far too often, so I'm not going to use it. It's growing and growing and growing and growing. And EVs around the world are going to continue to grow. Little bumps in the road, no pun intended. What you're offering is this subcontracted management bit between the battery, the battery management system, and then how you get that data from the battery to wherever you want to go, whether it's managing your EV fleet or doing asset tracking. So you're offering that bit that just sits above the battery management system, and the system that then takes that data and gets it to wherever you want it to go to. Yes?
Correct.
Excellent. Okay, right. You then are in the privileged situation of interacting with lots of different vendors, lots of different manufacturers, lots of people managing batteries. So the value of this video to our community is, what are you learning? How do you see the future? Because that's the value.
It's a like this is a very important aspect of this whole technology, EV technology. So I will tell you some numbers for India. So what is happening now?
Please, yes, please do. Yes,
Yes.
excellent.
Yeah. So, like there are 4 5 major OEMs here, in India. Like for example, Amar Raja is one of the bigger player. Tata is one of the bigger player. This Excite is one of the bigger player. Now, if you see this top 3 top 4 companies, from last 1 or 2 years, they have already started acquiring bigger places and all, and they have made this information public that they are going to invest collectively around 50,000. You can convert it into USD, but like it's a big amount. And this is a billion-dollar market already. These plants are going into in completion stage by 2 year 3 year in phases. This is used up now. Right now the demand for India in the coming 5 years is around 100 gigawatt hours, kind of like that kind of scale. But we although with such kind of investment which has already been done, we are only able to fulfill the 50% around that. Still 50% is the lag, and where lot of people have already starting putting into it. Lot of new companies, even in last year or last 6 months, have started coming into it. Because if you see, like, these are battery OEMs. Battery OEMs are not only for e-mobility or automobile, because our discussion is around electrical vehicles, so that comes under the e-mobility. So this whole investment, and around 70 to 75% of this whole investment, is for the EV automotive. There are static batteries also. Let's talk differently. If you talk about the EV mobility, it's 70%. So there is a huge investment going on, and all these plants and all these things are going to create a greater market for these EVs. Even in India, apart from the bigger players, lot of startups manufacturing the EVs, because everything, 35 to 45% of the cost or complexity is the battery in any electrical vehicle. So now India is building an infrastructure where, having onboarding battery for any smaller company, even, it will be very easy. You can, for EVs, they can focus on their 50% of the things, and rest of the battery things are already sorted via in the infra we are setting. So there is a huge aspect, and I must say that, the audience which are, looking for these kind of skills, like this embedded and AI skills, because anyhow these are going to be interacting. And we are always talking about how extra capability on the edge we can provide. Even no, it's like 3 4 years back, in normal IoT device itself seems like a very dumb device. They do very whatever they have been to do, like AC kind of. This is that those normal IoT devices are also tend to do some kind of processing at the edge. So we have to bring the compute. So electronic background people, and if you talk about, let's say, if I'm right now, I wanted to start build this kind of products. At least if like I want to understand how this product works basically. Getting a lithium ion battery is, how it's easy is, and you just have to build, commercially off the shelf circuitries. Like, let's say, talk about battery protection circuit. You get BMS circuits in a very dirt cheap amount. And then what you need is, some modem basically, which can give you the GPS and GSM capabilities, the signals and all, so data transfer. That's also dirt cheap. So you have to combine this, these things, and you can start with a bare minimum, monitoring devices, like that can plug with a normal EV. The voltage is very lesser there, 1.11 volt kind of, and then you can scale, like, you can understand how these things work. So basically you are measuring the voltage, measuring the current consumption of from those batteries, and then you are processing some of it on the edge, and then you are sending it to the cloud. That's it. That's what
Yep.
exactly our
Yep.
product is, but in a much larger scale.
Yep. So that's interesting because we've been talking about edge computing, well, for the last 18 months on ipXchange. And we've always taken the view that if you take Tesla, for instance, it's just the biggest device in the world on wheels. That's basically what it is. And it's this massive, great big edge computer that's got wheels, got a big battery, and it communicates with the cloud. So what you're saying is let's talk about India. If, for instance, you took the biggest EV market and you called it e-mobility, whether you call the EV market, whether you call it e-mobility market, it doesn't really matter. What you're saying is that trend is going to work its way down into the ecosystem, and every single EV in India as an experience, because obviously it's this huge market where it makes sense to have EVs rather than polluting products. You're saying you're going to see that trend go down into the ecosystem, and you're going to see edge computing go into just about every e-mobility, EV car, whatever it is, and you're going to see that go down into the ecosystem. So edge computing is going to become an absolute reality now, today, not just in terms of managing the battery, but in terms of everything else. So all of a sudden, all e-mobility EVs will become just like Teslas. They're going to become big edge devices on wheels, and you're going to see that happening in the next 18 months. That's basically the trend that you're outlining, that you've just said. Is that true?
Exactly, it's true. Think that's why I wanted to coin this. So we are making world first FPGA technology based EV charger. So right now in the market, you will see 16-bit microcontroller or like so based on those EV chargers, right? Because if you see, battery and chargers are, these are the pointers where you are completing the whole EV cycle. That EV has
Yes,
to be
yes,
charged. So
yes.
we are making that product also. We had started late, like 1 year back, and we are working closely with AMD. And particularly we used FPGA. Why? because this FPGAs comes with Cortex ARM A9 kind of processors, which have much larger capacity. And right now we are working toward revolutionizing the whole EV charger game in India or global. We are making it in from the whole global and Indian perspective. So, now coming to your edge computing, we are very cautious that we'll bring edge computing onto our devices, because that's a need. Right now, if you see in EV, already ADAS systems are there, and that requires edge computing. So, 50-60% of things are already based on edge computing. You cannot wait for cloud and manage the latency between this communication where you're driving in real time. So already those systems are there on the places. The Tesla you mentioned, they are working, like on the god level onto ADAS system. But on the battery side, still this area is not much explored, or kind of not, right now, due to the expansion of EV across the global stage, is happening now.
Let's not use the word explode. Let's not use that word. Let's not use that word.
Understand? Okay,
Let's use
let's
another word.
yeah. Okay, there's a story with that words also. We'll discuss later. So these things are happening. So on the battery side, we saw this problem. Edge computing is the fundamental tool through which we are solving that problem, basically, if you see.
Right. Okay. But you've got this huge market where India is electrifying its vehicles, whether that be fleets, whether that be electrical vehicles, be that e-mobility, whatever it is. And you're absolutely seeing this trend of edge AI going into all these devices. So in terms of our community, understanding and taking knowledge from this video, which is the whole point of doing these videos, is that they can see a trend in India where you are taking what today is very leading edge, no pun intended, edge AI computing on the edge, and you can see it absolutely being put straight into the EV market and then that market. So they should be very comfortable in understanding, if you're in Europe, for instance, or if you're in USA, or if you're somewhere in Asia, you can see that edge AI is going into transport and EVs. And here is a perfect example of India, of how you're, I hate to use this word commoditizing, but you're absolutely commoditizing edge AI into mass markets. That's basically what you said in this discussion in EVs. So that's a very interesting discussion. Thank you. So Mandy, that's Vanix. So how the world can learn from what's going on in the EV market in India. And you've helped us understand it. Thank you.